Hello engineers. So we have a lead code question on our screen that is contains duplicates. So let's read the question. Given an integer array nums, return true if any value appears at least twice in the array and return false if every element is distinct. So we will be given a integers array and we have to return true if it has duplicates. In this case, like 1 appears twice, so the output is true. And if it doesn't have any duplicates, like in this case it has all the distinct elements, we have to return false. So let's discuss approach. This is a question of set. I mean, there are other approaches as well, but uh, this is a standard set question. Let's see how we will approach this. So first of all, we'll have our array. One, two, three, and one. So this is one case. And next, we have to iterate over this array. So assume we are on the first element. We'll have to maintain a set as well. So let's have a set here. Okay. And okay, so that's enough. So before adding anything into the set, we'll first check if that number already exists in the set. So let's see. One doesn't exist in the set. So next we'll add that element into the set, like here, one, and keep and like move the pointer forward. Now 2. Again same question. Does it exist in the set? No. Then we'll add it into the set. Next, let's move forward. 3. Does it exists in the set? No. We'll add it into the set. Here. So does it exist in the set? Yes. We'll not add it into the set and just return true. It's a duplicate. If we iterate the same process for the other one, and we'll just have to change this 1 with 4. And does this 4 exist in the set? No. We'll write it into the set. Like here. So that's the way to do this. And before discussing another the solution of code, let me show you like another approach for this. So what is the brute force of this? Brute force can be to have a nested loop, like I can have an outer loop and I can have an inner loop, and if I'm on I, I'll compare with every other element, and if I found another one, means that's a duplicate. That's one brute force approach. Another one is sorting, and if you sort this array, so here doesn't have duplicate, but what happens if you have a duplicate here? So you have to sort this array, then what it will become? It will become something like this. 1, then again 1, then again 2, sorry, once 2 and again 3. So once the array is sorted, what we will do? You will compare current element with the next element, and you'll keep doing it for the whole array iteratively. That's one approach. And what we have saw in the first attempt was the hash set approach, because I mean that's the simplest one. And let's see the code as well. So I'm doing it in JavaScript. Both the code are same, and it's just a bit simplified. There's no change in the logic. So what we are doing, we are creating a set here, and we are looping over the nums array, and before adding the element into the set, we are first checking for duplicacy, and then we are adding the element into the set. And if the whole iteration on the array is done and still you have not returned true, means obviously there is no duplicate in the set, sorry, the array. And let's try to run this code in LeetCode. Contain duplicates, description, same code. Let me run it again, and I'll submit again. Yeah, that's our duplicate contains duplicate question. And next question is valid anagrams. So this is a LeetCode question, valid anagrams. First, let's see what's an anagram is. What is an anagram string? A word or text formed by rearranging the exact same letters of another string. So that's the definition of an anagram. So we are given two strings. Okay. We have to return true if T is an anagram of else false. So we have two strings. Like, let me write it here. We have a string anagram and we have a string nagaram, and we have to tell whether these are anagrams or not. So let's discuss approach number 1, that is sorting and comparison. So let's see this first. If we sort this string, what will it result to? A sorted S is equal to A and again A, then G, M, and then R. Seems right? Okay, seems right. So we have sorted S, and we'll also sort T as well. It will again give us the same string, and then we'll just compare them. If sorted S same as sorted T, then it's a valid anagram, else it's not a valid anagram. Okay, let's discuss another approach. For this, we need to understand a concept that is ASCII values. So because I'm doing this in JavaScript, uh, here A has a ASCII value of 97 and Z has, I guess, 117. It's 122. So all the numbers like B will have 98, C will have 99, and the sequence goes on. I have already written here in the table. And another condition of anagram is frequency of character of a particular character in S should be equal to frequency of that character in T. Then only it's possible to form an anagram. That seems obvious because if we see both sorted strings, A appears exactly 3 times, G once, M once, N once, and R once. So in this approach, we'll have a hash map like this. And okay, no, I'm doing something wrong. So in this hash map, we will store character and frequency. So we just understood that one condition to form anagrams is in both the strings, frequencies should match for a particular character. And we have also found that each character has a value, ASCII value of 97. Just a numerical representation of a alphabetical character. So A is 97, B is 98, C is 99, and so on. Z is 122. So if I iterate over the string and just store For, the better way is this one. A, 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 not this one, but anagram. A, G, R, A, M. We have to iterate over this array of strings, array of characters. So first we are at A. What is the frequency of A? There are no A at in our map, so we'll say we have one A here and one. Again A. So we will not create a new entry but just update existing frequency. We'll say the frequency is 2 now. G. G is also once. R. R is also once. A. So we similarly will not create a new entry but just update from 2 to 3. And next M. Okay. And you can do the same process for Nagaram with another map, and then you will compare the frequency. And so you will have a similar character to frequency map for both the strings. So this was for anagram, this was for nagaram. Okay, let's take it one level up and make it even simpler. So as we have already discussed that each character is represented by an ASCII value. So can I say if I have a in anagram, I must have an A in anagram as well. If I have N in anagram, I must have an N in anagram as well. So instead of creating two maps, what we will do, we'll increment the frequency of A for anagram and will decrement the frequency if we found that A also is present in anagram to maintain a balance. Let me tell you how. So here Anagram. Then we have Nagram. So I'm at A and N. I'm looping over the string. So my pointer is at A and N. I'll say count of A is 1. Count of N is also 1. Let's move forward. Then I found N. For the first string, I'll keep on incrementing the frequency, and for second string, I'll reduce it to maintain a balance. So we are at N and A. Let's increase N. Oh, sorry. Here we did a small mistake. We have to increase frequency of A and we have to decrease frequency of N. So we had no N's, so it should become -1. Now at N comma A. Here we will increase the frequency of N. So N should become -1 to 1. In A, we'll decrease A. A should become 1 to 0. Let's move forward. Again we have A. We have to increase A. From 0 to again it becomes 1. And G, we have to decrease frequency of G. G from 0, it has no occurrence in our map, so it's 0 and we are decreasing, so it becomes -1. Now we are at G and A. For G we have to increase. So -1 becomes 0. And A we have to decrease. So -1 should become 0 now. Now we are at R. We have to increment R once and we have to decrement R once. So R still stays at 0, +1 and -1. R is 0. Sorry, it seems like I did a small mistake. From -1, N becomes 0, not 1. And we are at A. So we have to increase A once and we have to decrease A once. So if you add 1 and remove 1 from 0, it still stays 0. No change. And we are at M. Still the same. There is no frequency, so you start with 0 and you add 1 in 0 and you remove 1 from 0, so it stays 0. And last, you have to compare every character's frequency should be 0. If it's 0 means we had a balance of addition and subtraction. And for A it's 0, for N it's 0, for G it's 0, for R it's 0, for M also it's 0. So we can say anagram is these two strings S and T are anagram. So let's write here. So here it's a valid anagram. Can we iterate the similar solution for a failing case? Let's try. Do we have a failing case here? Yes, rat and car. If we apply same approach, let me create a line here for a separation, and we have R, A and T. We have C, A and R. Okay. So we are here at C. Our pointer is at R and C. And R is 1 because incrementing, and C is minus 1. A. A is, if you add 1 and remove 1 from 0, it stays 0. No effect. And T. You add 1, and for R you remove 1. So it's 1, and if you remove 1, it becomes 0. So finally, if you say R is 0, okay. But C is minus 1. T is 1. So we have two non-zero characters. So that makes rat and car not an anagram. So you might have understood our logic, and let's see the solution, a code walkthrough of this. So this is Java solution, but I am preferring JavaScript because I know JavaScript. So first we are converting T into array character, and we are filling it with 20, we are filling it with 0, means an array of size of 26 all filled with zeros. So representation of that is this comment, and we are assuming it's an anagram. I guess we could have done better instead of using this variable, but I'll show you that in a minute. So for all the S characters, we are converting it into an array, and for each character we are looping over it. So we have created an alphabet array. So the approach I said you of map, right? So at A we are incrementing, decrementing. At N we are incrementing, decrementing. So this is same resemblance is this array, because see the array is of fixed size of 26, right? So it should be something like this. Should be something like this, and you'll have indexes here like 0, 1, 2, 3, 4, 5, 6, 7, until last it will go to 25. And at 0 we denote it with A, and we'll store here frequency. So like here in the case of rat and car, A will be 0, then R will have some number, so that R will store 0, then C will store some -1, and then A already has 0, and T will store some 1. So this was just a map representation, and we are not using map because an alphabet array of fixed size fulfilling our condition. So looping over S array, and in the our alphabets array we are converting the present character into zero to 25 range. How we will do that? So we have already learned that A is 97 and Z is 122. So you have to convert this into 0 to 25 index. You'll subtract any characters ASCII minus A. So suppose you want to get index of B, what you will do? You will do B minus A, like 98 minus 97 is equal to 1. So B has an index of 1, A has an index of 0, C has index of 3, and so on the list goes on. So we use this method. So this gives us some number, and A dot character code dot 0, this will give us 97. And as I have said, in the case of first array or first strings array, we are incrementing the frequency. So at that index of the array that denotes the alphabet itself, we are incrementing, and parallelly we are decrementing as well. Like I have said here. So here we used char, that is coming from the S, and same index in the T strings array, characters array. So we are not doing it with two loops. Single loop is satisfying our condition. We are using the index to move forward. So it increments and this line decrements. With this, our whole iteration to form a map kind of thing works. And next, as I have said, we have to count all these frequencies to be 0. So in the alphabets array, if the character is not 0, then it's not anagram, else it's an anagram. So we have assumed that it's an anagram, and if it passes all the conditions, then it's an anagram. Else if it fails, if it's a non-zero in the alphabets array, then it's not an anagram. So let's discuss the approaches. As I have said, sorting. We could have done it with sorting. So sorting is n log n, and space is constant because we will not use any kind of space in that. In the hash map approach, uh, what I have told here of n, because we are maintaining a hash map of size n is the string length, and space is constant, or O of k. And space is constant still because it's a fixed size of 26 alphabets, 0 to 25 index. So a fixed size always counts as a constant size. And another approach we have tried, that is array, fixed array. That's also O of n complexity, because we are iterating over each element, each character once, and space complexity is constant because it's a fixed 26 characters length array length of 26. And that's all. Uh, this was an interesting question, though it was a simple, but it will require you to know about the concepts of ASCII values. And let's run this code. Uh, as I have said, I can improve this. Will not use this, and instead of for each, we can do for const char comma index of this array. Sorry, here it's not necessary. The reason we have used this is anagram variable, because from inside of for each you can't return. You can just return outside this callback. So if you want to return outside of this function directly instead of using this, so we'll do something like this. A bit cleaner solution. Um, I guess we did something wrong here. Let me see. What wrong we are doing? I'm not getting what wrong I'm doing. We are converting a string into an array by spread operator, and then array dot for each what it's saying. Let's read. Unsafe token. Oh man. These kind of silly issues. So we must put a semicolon before this. Looks like working now. I guess we have to take care of the case if both strings are not of same length, then it can't be anagram. So I guess I should include this in my notes as well. So that's all. This question is done. The next lead code question we have is to sum. And so what the question says, given an array of integer nums and an integer target, return indices of the two numbers such that they add up to the target. So we are given this array of integers and we are given a target of 9. We need to return indices that forms the target. Here 0 and 1, like 2 and 7 will form 9. So here let's start with this one. Obvious brute force will have a double loop. We'll start with 2 and we'll loop over the next inside another loop, and we'll like sum both, and if it's forming target we'll return those indexes. That's obvious brute force approach. And another thing is, so this is the hint. While scanning each number, ask what number would I need to reach the target and have I seen it before. Use a structure that supports fast lookup while iterating once. Okay. This question asks us to return the index. So the approach is, we have discussed the brute force, but let's discuss the optimal approach. We'll have an array of 2, 7, 11, and 15. Okay. We'll need to maintain a map like this, and what this map will hold is, it will hold the number and the index. So the number and the index. So, and what is the target is 9. Target is 9. Okay. Difference is equal to n1 minus n2. So suppose we are at 2 and what is the other number I need to form this? We should do this instead. Target is equal to 2 numbers. 9 is equal to current number, that is 2. 2 plus x. X is equal to 7. Okay. So our question is, I am on 2. I need 7. Have I seen it already? I'll see the empty map. I'll say no, I haven't seen that. So what I'll do, I'll just note it down. I have seen 2 at index 0. Now I'll move to 7. Again, same question. I have 7 to form 9. What I need? I need 2. Have I already seen 2? I'll find in map. Yes, I have seen 2. Okay. So what is the index of 2? It is 0. And what is the index of 7? That is 1. So that makes our answer. Answer is 0, 7. So that's the approach. We'll have to maintain a map of number and the index. And we have to keep iterating over the array. And we have to ask this question. I need to make up 9. I have a number that could be like 2 or 7. And what else I need? Does that already exist in the map? If yes, then current index, and though that index is my answer, else I'll note that down in the map. So that's the approach, and let's see code as well. So that's Java solution, but we'll do in JavaScript. So this is a brute force approach. We are having an outer loop, we are having an inner loop, and if I is equal to j means I am on the self number. So if I am on the self number, what I mean by that is suppose I am here. These are two loops. I am on 2, our I is on 2, and our j is on 2. So I can't like sum myself to form that number because we need two indexes, right? So that's our exclude condition. And if both numbers sum the target, I'll just return the index. That's the brute force approach. Let's see the optimal hash map approach that we just saw and discussed. So we are creating a map that will store number and its index, and we are iterating over the nums array here. And what is the complementary number that I have said? Complementary number is equal to target minus myself. So target minus the current number. And if map has that complementary number, then we have to return my current index and the index of that number that is stored in the map. So map.get complementary number. So map.get key gives us the value, and the value is the index. And if that's not the case, we'll set the number and the index in the map. Let's try to run this. So the question name is to sum. So that's already have tried that in past. So okay, cases are running fine. We submit. So it's working fine. If we come to complexity, we are iterating over the array, so it is O of n, and if we take space complexity, so it's O of n, because at max the map size can be same as the array size. So we have the next question, LeetCode, that is group anagrams. So group anagrams, what does this question say? We are given an array of strings. Group the anagrams together, you can return the answer in any order. So this is a array, and this will be the output. So bat is single because it has no anagrams in this array. When we have nat and tan, then we have these three: 8, eat, tea. So this is a kind of medium question on LeetCode. Group anagrams. Let's see. So let's discuss the solution of this question. I have tried many questions here, means many solutions, and I have optimized it. So this is a sets question. Let's discuss this. In anagram, we have already discussed this anagram question in past. The two strings are anagram, example and tan. When characters of that string can be rearranged to form the another word. Example, you can arrange A and T to form TAN. And if you sort, it will become A and T will remain A and T, and if you sort tan, it become A and T. So another property of anagram is, in a sorted order, anagrams are always equal in comparison, string comparison. So we will iterate over this array. Okay, let's write it down. This is our array, and we'll also have a hash map here. Hash map. So the hash map will store sometime this Obsidian or Xkillidor doesn't work as expected. So word in sorted. So in the map we will store word in sorted, and in the value we will store all anagrams of this word, or better we say anagrams array. So let's keep the pointer here to understand the question. We are at eat. What eat becomes when it's sorted? It becomes AET. So first question, does this AET already exist in the map? In that case we have to update its value. If that doesn't exist, then we have to create one. So AET, and the anagram it hold will be EAT. EAT. Okay. So next our pointer moves forward, that is T. If you saw T, what will it become? It become EAT. Sorry, AET. And again the same question, does it exist in the map? Yes. In that case, we'll not create one but update existing one. We have to insert the TEA as an anagram. Another thing, will not store anagrams array but will store anagrams set. Or I guess we can store array, that shouldn't cause any issue. So the next thing is TEA, not tan. What if you sort it? TAN becomes ANT. Does ANT exist in the map? No. We'll create one. ANT. ANT will hold the anagram TAN. TAN. ATE. ATE. What if you sort it? It becomes EAT. Now add this ATE in anagrams. ATE. Now NAT. What NAT becomes unsorted? ANT. So let's update, insert another one, NAT. Now BAT. What it becomes unsort? It becomes ABT. ABT doesn't exist, so let's create one. BAT. So it will hold BAT. No, it will hold BAT, but it will be ABT, not BAT. ABT. Because we have already said it is the sorted word and these are anagrams list. And to give the result, what we will do, we will just return all the anagrams array inside an array. So it's an array of array. So let's see, does our solution match? So output should have a bat. Yes, we do. Nat and tan, nat and tan. 8 eat tea. 8 eat tea. So that's the approach for this question, and let's see solution. So the solution is very simple. It's in JavaScript. First of all, we have created this map. We are iterating over strings as we have discussed. So what is the key? Key is we are creating the string into an array to sort it and to join it. Sort the array and join back to form a string. So that's the process of making EAT into AET. We have got the key. Does this key already exist? If not, then we'll create one. Okay. Now, after we have created, inside that key, we have to push the current string. So inside for this AET key, we are adding EAT. We are adding T. We are adding 8. That's process in this line. And after that, we are just returning all the values inside an array. All the values anagrams array inside an array. So that's the solution. And if we talk of complexity, so it's O of n, because iterating over all the array. O of n, and again we have to consider this thing, sorting. So for each string we are sorting it as well. The sort logic is k log k, where k is the average string length and storage is of n into k. Where k is average string length. Let's try to run this solution. Group anagrams. Already I have tried it. So I'm running it again. Okay, all cases passing, and it's accepted. I mean, our solution is a working solution. So the next LeetCode question we have is top k frequent elements. So top k frequent elements. What the question says? Question says that we'll be given an integers array. We will be given a k, that is an integer, and we have to return top k elements. Like we were given k equal to 2, then we have to give top two most frequent elements. The top two most frequent is 1 and 2. Another example, in a single array, what is the most frequent element? That is 1. So let's draw a diagram for this. Hmm. If we maintain a map, if we maintain a map, so let's iterate. So one brute force approach is you sort this array, and have a double loop, like a nested loop. And if the case 2, then you'll get all the most frequent elements in a sorted manner, and you can just pick them. But let's do something better, a better optimal approach. I'm not showing that nested loop logic in detail because that's very obvious. So what we will do, so we'll iterate over this array. So what this will store? What will this store? This map. This map will store the number and its frequency. Okay. So again, if we are if we found the entry in the map that we are looking for currently, we'll update its frequency, else we'll create a new entry in the map. So let's iterate. We have one. One doesn't exist. Let's create one, and frequency is one. Then again one. Then again one. So it will become one, then become two, then it becomes three. Okay. Now we are at two. So let's create an entry for two, and its frequency is one. Again, we'll move forward. Now again, we'll increment this. Now we have three. Three has an occurrence, frequency occurrence of one. Now, if you get all the frequencies, we have all the numbers and their corresponding frequencies. Okay, now we want to sort it because we want top k most frequent. If we sort it, how we will get it? If we sort it based on frequency, this will remain unchanged because 3 then 2 then 1, and then we have to pick top 2, top k, that is top 2, and in top 2 we'll have this thing, and our result will be 1 and 2. So this finally will become our result. Let's see this in code. First of all, we'll create a group, that's a map with the name of groups that will hold number and frequency as key value pairs. For the nums, we'll iterate over it, and in the groups in the map we'll set for the number, if the group has the number, then we'll just increment the frequency. Groups dot get num plus 1 means this number's frequency plus 1. So we are incrementing the frequency, or else we are just placing frequency as 1 because this is the first time we have found it. Next step that I have told, like we have to sort this map based on this frequency. So groups dot entries dot sort. Groups dot entries gives us an iterator, so we can sort over it. You can't directly sort a group, so we are first converting it into an iterator. I have told here, I guess. Map prototype dot entries method gives us a map iterator. So it's a map iterator that has key value. So we can assume it like an array of key value, like this, something like this. Array that has again array as key comma value. Then again we have a key comma value, and so on. So this gives us the array, and we are sorting it based on frequency, means descending order. B minus A is general way to sort numbers, but we are doing B of 1 minus A of 1 because what is 1? 0 comma 1. 1 is value. Value means frequency. So we are sorting over frequency. Okay, we have got sorted map. Now sorted map dot slice 0 comma k. Dot slice gives us top k, means top 2. So we are saying we don't want the whole map, but we want only top 2 items of the map. Okay, top 2 entries of the map. And then again, because this sorted frequency in entries is an array that I have told, like this gives us an map iterator. So sorted frequencies array looks like this, something like this. Key is 1, value is 3, and again key is 2 and value or frequency is 2. So this is something our sorted frequency entries look like, and it have something more as well. When we slice it by 0 comma k, and if k is 2, then it will give us first 2. Then in the map, what we are saying, give me numbers and frequency, that is this thing, key comma value pair, and I'm mapping it to just number. So this becomes something like just 1 comma 2. Number comma frequency, but we are just keeping only number. That is the map, right? Map returns a new array. Like map is used to do transformation with an existing array and return a new array. So that's the whole solution. And if we talk of complexity, so we are iterating once, so it's O of n, and map storage is like map can hold or max n items, the size of the array, so it's O of n. Let's try to run this. Top k elements, so I've already solved it. Let's solve it again, means run it again. So that's the solution of this question. Top k frequent elements. Next LeetCode question. Product of array except self. Product of array except self. Let's search this question in LeetCode. So there are few constraints for this problem, that we will be given an integers array and we need to return another array answer, such that answer of I is equal to the product of all the elements of the nums except nums of I. So if we look this example, so here except 1, all the products like 2 3s are 6, 4s are 24. Now here except 2, 1 into 3 into 4, 12. Now here except 3, that is 1 into 2 into 4, that is 8. Here, that is we need to exclude 4, that is 3 into 2 equals 6. So this is something we need to do, and I'll tell you how I did that. Initially I tried something like this. That is brute force. So okay, so let's discuss brute force first. So this is the thing. if I loop over it twice, I have to exclude self. Okay, so this is a solution. I have to exclude self. So 1 into 1, nothing. 1 into 2, 2. Right here somewhere, 2 plus 1 into 3, 3. Actually, we are making product, right? So 1 into 2, 2. Into 1 into 3, 3. Into 1 into 4, 4. Okay, now here we are at 2. Let's use an arrow here. So that is 2 into 1. Into, we have to exclude the self. It means will not do 2 into 2, but next 2 into 3 into 2 into 4 into 3 into 4. Next, again similarly for 3, that is 3 into 1 into 2 into 4. 3 into 1 into 2 into 4. Sorry, I guess we should exclude self, right? So I can't take 3 here. I can't take 2 here. Now last one. So in the case of last one, we can't take 4. So it is, we have to exclude 4, right? So it is 1 into 2 into 3. So here we have excluded 1, here we have excluded 2, here we have excluded 3, and here we have excluded 4. That gives 24, 12, 2 into 4, 8, 2 3 is 6. Okay. Another thing, if you see the hint, what it says, you must write an algorithm that runs in on O of n times. So the double nested loop won't work. And you can't also use division operator. Okay. Think how you can efficiently utilize prefix and suffix products to calculate the products of all the elements except self for each index. Can you pre-compute the prefix and suffix product in linear time to avoid redundant calculations? Okay. So it's giving us a hint of something like prefix and suffix. Okay. There is a pattern here. If you recognize that if you want to get the product at second index, is it the product of all the items on left and all the items on right? Product of 1, 3 and 4. Yes. Similarly, if you take example of 24, is it product of everything on the left and everything on the right? There is nothing on left, so no, and everything on right is 2, 3 and 4. Yes, 2, 3 and 4. Okay. So can I say at index 0 it will be product of left, that is plus. So product of left and product of right. So here is the concept of prefix and suffix. Let's create an array. We'll call this left product, and we will call this right product. Okay. So what is product of 1? What are all the left products of 1 at index 0? So there is nothing, we'll say simply 1. Okay. So index 1 means number 2. What are all the left products? Still 1. Okay. We are not taking 0 because product should be 1 at least. If you include 0, it will become 0 for everything. So here, what is left product? That is 2 into 1, that is 2. And here at 4, what is left product? That is 3 into 2 into 1, that is 6. And the right product. Here what are right products? That is at number 24, that is 12 into 8 into 6. Oh sorry, it's output. I'm looking at output, but we need to look for the upper one. Inputs nums. So here at 1, the right product is 2 into 3 into 4. That is 24. At 2, all the right products is 3 into 4. That is 12. And at 3, all the right products is 4. There is just one element, that is 4, so we'll just write 4. And at the extreme right, at 4 there is nothing else left, that is 1. So we made two arrays here, that is left product, that is right product. For any element, if I have to get the product except self means left product, we can say left product into right product. And if you multiply this, what we will get? 1 into 24, 24. 1 into 12, 12. 2 into 4, 8. 6 into 1, 6. So 24, 12, 8, 6. 24, 12, 8, 6. So this is the logic. We have to do something like this. To get the product except self, we need to get product of left, get product of right, and multiply both left and right. So let's see how we will do this with code. So here's the solution. We have to return a result array, so that's an empty array, and instead of this we'll see other one, top one, because it's a bit more minimized code, so it lacks some readability, but the concept is same obviously. Okay, so we have a result array, we have a left product array, and we have a right product array. All these arrays are empty, and we'll start with one because product needs to start with one. Product means multiplication. So for the first one we are iterating over it, and for each element we'll just add it into the array, like here we did. For one we have added 1, not added 1 but the product was 1 because there was nothing. Initially product was 1, right? So if I have to write here at start product equal to 1, so here because there was nothing we wrote 1, what was the initial product, and here at 2 we did initial product into, means the product into the left item. Product was 1 and then left item is 1, then that became 1, and here the product becomes, still stays 1, and here we do product into 2, that is 2, and here at last at 4 product is 2. So 2 into 3, that is 6. So to maintain this logic we need to first keep the product in the array and then multiply the product, multiply the current element into the product. Similarly we have to do this for the right one. Okay, so in the right one we have to do it in reverse order. So we are going from nums of length -1 to 0, and we are doing unshift. Unshift means inserting from the right. We are not inserting from the left, but we are inserting from the right. and similar approach. And next, for this nums array, we are again iterating over it, and in the result array, we are pushing, means inserting into it left product into right product, and we are returning the result. And we have cleaned this a bit here in this below, that we are directly pushing, but we are reversing the right products array. So this is the code. Let's try to run the code. Products of array, and I have already tried it. Let's try to run it again. And running this code, submitting. So that's it. This solution is done. Question: products of array, LeetCode. Next LeetCode question we have is a valid Sudoku. This question is really straightforward. I mean, this is a medium question, but let's see. Mostly it involves a couple of math concepts, and so we have three conditions here for a Sudoku board to be valid. So there is a 9x9 Sudoku board, and we have to determine whether it's valid or not. Only the field cells need to be validated according to following rules. Each row must contain 1 to 9 without repetition. Each column should contain 1 to 9 without repetition, and each sub box, that is this small box that is of 3x3, it should also contain 1 to 9 without repetition. So we need to assess these conditions and tell whether a Sudoku board is valid or not. So the logic is very simple. I mean, let's see how we'll do that. So this is a question. So as we have saw, like, there are three conditions to check whether a row contains without duplication. We can do a nested loop with I comma j. Similarly, with column we can do a nested loop with I comma j, and we need to maintain a set for to determine whether this is a duplicate or not. The real problem starts in this sub box of 3 cross 3. So if we can explain you with the code, so this is our Sudoku board. Let's try to divide this. One, two, three, four, five, six. Instead of I should have done this thing. So this is our Sudoku board. We'll maintain a set for row to keep track of duplicates. We'll keep a set for column to keep track of duplicates. We'll also have a set for sub box, that is 3 cross 3 box. So this is our set. So because this is a 2D array, you need nested loop for traversing both row and column. So that's how you will do this. This is our nested loop, and we are checking, is this number a duplicate in this row? If such, we are returning false. So that's simple. And similarly we are doing for the column, and for the column we are swapping board of ij with board of ji. So instead of going left to right, we'll be going top to bottom. That's simple. And here for this sub box, we know there are 9 sub boxes, so let's add, this is one. Oh, sorry, I mean, if I write, it will be so small that we can't kind of understand it clearly. So first, second, third, fourth, fifth, then we have sixth, seventh, 8th, and this is the 9th. There are 9 sub boxes. Okay, 9 sub boxes, right. Next thing you need is, for each sub box you need its start row and start column. For example, see here. How can you check in these sub boxes? Only if you know at what row and what column they are starting. If you know that, then you can do a nested loop of 3 and 3, then you can do similar check duplicates logic there. The question is, how will you know that? So there is a pattern if you see here. So if you see for rows, the sub boxes are starting at 0, 3 and 6. 0, 1, 2 and 3 another box, 4, 5 and 6 another box. So it's same 0, 3, 6, 0, 3, 6, 0, 3, 6. Sorry, it was column. So every sub box is starting at 0, 3 and 6 columns. I need to note down here. Column start. This is column start, okay. And now if you see at row start also, similarly row start also starting at 0, 1, 2, 3, 4, 5, 6. So row start is also at 0, 3 and 6. Now the question is, how will you know? How will you get this start column starts and row starts indexes? So for this you need to understand, you need to kind of see few patterns in this. The patterns are, the start column is 3 into box number modulo 3. This gives you 036, 036, 036. 036, 036, 036. Great. How? Let's iterate this. For the box 1, first box the index will be 0, right? So 0 modulo 3 is 0 and 3 into 0 is 0. Okay. Next, if it is 1, 3 into 1 modulo 3 is 1. 3 ones are 3. So 3. Again 6. So the pattern will keep repeating itself. 036, 036, 036. Again you need row start. How you will get row start? So here box number is 0, 1, 2 and here 3, 4, 5 and here 6, 7, 8. So we can see a pattern like it is somewhere related to multiplication and division. So the formula is here. So start row is take the floor of division of box by 3. So 0 by 3, 0, 1 by 3, 1, and again same the logic repeats. And if you can see this here, if it is box number 0, 1, 2, 3, if it is box number 3, 3 by 3 is 1, 1 into 3, 3. So here you will get row number 3. Let's iterate it for this 7th box, 1, 2, 3, 4, 5, 6, 7. So here you need a row number of 6. How you will get that? At 7, 7 divided by 3 is 7 divided by 3 is 2.3. If you are taking 2.3 ka floor of 2.3, that is 2. 2 into 3, that is 6. So here you will get the 6. So this is something you need to know, and it took a while for me also to figure out this pattern. So you have 9 boxes, and from those 9 boxes you need to get column start and row start. After you get that, you'll just loop over with a nested loop of 3 times. So for row 3 times, and for column 3 times, for row 3 times. I've done it reverse, you can do it reverse. The result will be same. And we are checking if this is duplicate or not. And if it is duplicate, it return false. And if this Sudoku board has passed all the 3 tests of row, column, and the boxes, and still it's not returned, means this is a valid Sudoku, means we have to return true. And the logic of this duplicate is very simple. You get a number and you get a set, and it just checks does that number already exist in the set. If so, we'll return true, else we'll add that number into the set. So this is the logic of the Sudoku board problem. And what I was telling to reverse here, instead of starting with column and row, we have also done it with row and column. So it's just preference or style of writing, and doesn't change the logic how the program runs itself. And if we talk about complexity, the complexity of this would be a kind of constant. Why? Because this is a fixed size Sudoku board, right? But still, for every cell we are uh, doing it nested loop row, so it would be of n square complexity, and we are creating a of set of size 9. So that is O of n, complexity of space. Space is O of n, time is O of n square. Also mentioned that Sudoku board is like fixed size, so technically both are constant, because the board is not gonna increase from this. So that is the point. let's try to run this program. I've also kind of tried to log what would be the start of column and row for each boxes. So box 0 is 0 at 0 comma 0, box 1 is 3 comma 0, 2 is 6 comma 0, 3 is 0 comma 3, and all that. So let's run the program. I've already tried this. We're trying it again. So that's it. This question is done. Main logic is this thing. I mean, if you can understand this one, uh, if you can understand this thing, how we are using modular operator and division operator to get the indexes of rows and columns, and it depends upon the box number, box index, then this question is not very difficult. Next lead code question we have is encode and decode strings. So this question is, let's search it on LeetCode. So this is a premium question. I mean, you have to purchase subscription to do this. So instead we will do it on NeetCode. I have the link copied here. So I've already done this question. Let's understand the approach to do this. And encode and decode strings. What the question says: design an algorithm to encode a list of strings into a string. Okay. Encoded string is then sent over a network and is decoded back to the original list of strings. So the question is, we have to implement two methods, encode and decode. So it's something like this. This is the input. You have to encode it into something. Let's say encoded string. This is something, and from this encoded string you need to convert it back. Convert it back into original array. So that is the process. Decode. Encode. So these two methods we need to implement. So initially it looked simple because of this example. Because of this example, it looked initially very simple. How, I'll tell you. So you have this, you say what key, I'll join this array into a single string with a separator. Let's say a separator is this thing, a colon and semicolon. So this becomes something like this. So the encoded string will be this thing. Okay, good. You'll iterate over each of the item and concat. Add the word and add the separator. Okay. Then again you will loop over this string, and if you find this separator means you have found an end of the word, then you will make it a insert into the array as a string. Similarly you will do for this, similarly you will do for this, similarly you will do for this. This approach looks simple, but it has some drawbacks. Even though this approach will make our all test cases pass. So I'll show you the code. So in Encode, so to handle this case, when the array is empty, we are returning an empty string. We'll have to handle here in the decode. Okay, and we are having a results string, and if okay, we have the results string, and we are iterating over the strings array, and first we are pushing the item into the string concat, and in between we are adding separators. So we have this separator here in between lint and code, and in between code and love, and between code and love and you, but not at the very end. So we are handling that case with here. So if you are not at the end, keep adding the separators. This is our simple encode function, and in the decode we are just splitting the string with this separator. So it converts this string into the array. Okay, simple, but this is not a good approach, and let's see something better now. A robust format is this. So you will have length and then a hash. A hash is not mandatory, you can have any character, we are choosing hash. Then the string, then again the length of the next word and hash and the next word, string itself. Example, lint code and a colon and s. This array becomes 4 hash lint, 4 hash code, 1 hash colon, 3 hash yes. And now by looking this string, we see that we can convert it back to array, because it says we have 4 words of 4 length word ahead. This is lint. This said we have 4 length word ahead. Okay. This says we have 1 length word, that is a character, that is colon. And again we say we have a 3 length word, that is s. So we have to achieve something like this. Let's see how. So you can ignore this. This is just an improved and a bit more cleaned version of the same algorithm as above. So we have seen this approach. That is a simple one that I have told you, but it has drawbacks. Uh, but I haven't told you what are drawbacks. First of all, this will fail when this approach will fail when the strings is, so let's write here failures. Strings is this. So because this is a single element, will not have any separator or anything, we'll just have a string that is empty, and if string is empty we are returning empty array. So we have lost and this to this. That is a failure case. Another failure case, what if strings is this operator itself? You will convert this into this thing, this string and the separator. I'm doing some mistakes here. I'm not able to revert it. Hmm. So we are converting this array into this string, and we will convert this into two empty strings because that's our separator. So we saw like the drawbacks of this approach, this simple approach. Let's do something better. So we have to achieve something like this. I have told you. Loop over the strings, note down its length, concat hash and the string, and keep till you reach far end and complete the whole array. This is encode logic. So encode logic is here. Simple. You start with empty and length, hash, and the string. Do it for all the strings in the array. Return the result string. Okay. Now I have cleaned this function a bit more, and that is more readable. Let's see that in the decode what you are doing. So here's the example. So suppose the string was this hello and world, an array containing hello and world, and the string will become 5 hash hello 5 hash world. Okay, so we'll keep looping over this string one character at a time till we reach at very end of the string. Okay, so word length, let's initialize with empty. So we are in search of a word till we find hash. Let's get the length. So here in this case it will be 5. We'll collect the word length and we'll keep the pointer forward. And now we have to skip this hash also. We have skipped the hash with a moving our pointer forward. And next, word length, we are converting it into a number because see, word length is string, right? So convert into a number, and we are in search of a word, so let's initialize it with empty string. Now the length is 5. We got the length 5. Now we have to collect 5 characters. Now we have also skipped hash. We have to collect 5 characters because that is our encoding logic. So we'll loop exactly 5 times. Start with 0 and till the length, till j is less than length. Okay, and we'll keep concatenating that character into word. So that will make our word formation. It will be H, then E, then L, L, and O. Okay, and we'll also keep uh, progressing on our string pointer, our main pointer. And once we are done with that, we will push that word that we have just collected into our array, results array. And we'll keep repeating this till we are like out of the string. We have exhausted the whole string. So this is our decode logic, and we'll just return the result. Above one is also similar, but it's a bit more difficult to read version. Like I have changed the for loop to while loop, these kind of small improvements. So let's talk about the complexity of this program. The complexity is, here you are looping n times. N means the array length, that is O of n, and here also you are looping to the string's length, means string length, that is length of all the strings of the array. Suppose we have hello and world, and if you combine these two, it will give you 10, and we have some these separators also, so that is also the thing to consider. But it's not growing exponentially, but it is still in the range at par with our our array length. So we can say the complexity is O of n and space is O of n because we are returning the result array, that is exactly same as what is the strings, what is the strings array, and in between we are creating this thing, result strings array, that is the result of the encode, I mean this thing. So it's also on par with what we are receiving as input of array or this length. So that makes this complexity as linear complexity. Let's try to run this program And as we have discussed, uh, this is a kind of paid or premium question. So we are on NeetCode site. Let's run this and submit. As you could have saw, the main logic is how you will iterate over this string and keep collecting the length, skip the hash separator, and collect the word. Keep repeating the process until you reach far end and at like end of the string. This is how you'll do this program. I mean this question, and this is done. We have the next lead code question, that is longest consecutive sequence. So one brute force approach of this is you can sort it. You can sort it. Let me try here. I mean, hmm. So what I was talking about is brute force approach. If you sort this, what you will get with you are left with is another array, that is 1, 2, 3, 4, 100, 200. Okay, after you have sorted it, you can do a linear pass and keep a counter here. Like currently the counter is 0. You are at 1. You are at 1. The counter becomes 1. Now you are at 2. Is 2 consecutive of 1? How you will check that? If uh, this is nums of I is equal to nums of I minus 1 plus 1. Nums of I minus 1 is 1 and 1 plus 1 is 2, and is this current number, that is 2 equals 2, means this is a consecutive number. So you'll increment the counter. Now you are here. Again same logic, you'll increment the counter. And you are at 4. You'll again increment the counter. Now you are at 100. So this comparison will fail. Now you are again at 200. This comparison will fail and you are left with this thing. The result is 4. Okay. Let's iterate this approach with a similar input. If you have one, if you don't have 2 here, if you have 1, 3 and 400 and 200. Okay, let's add a subject between. You are at 1. You have a counter of 1. Okay. Let me write here counter of 1. Now you go here. This comparison will fail. Then you will do again. You will start with 1. Now you are here. You will do with 2. Now here you will do with 1. Now you are here. You will do with 2. Sorry, 1, because there is no consecutive. So you can maintain this counter in a set or something. When you are here, you said the latest counter is 1. When you are here, you said okay, the old counter was 1, but because they both are not consecutive, I'll maintain another counter that is 1. Now here the counter is 2. Now here the counter is 1. Now here the counter is 1. And you will pick the highest value in this thing. So you can maintain a set. But why we are not going into deep discussion in this approach? Because there is a constraint. You need to see that you must write an algorithm that runs in O of n. So there is no way you can try sorting, because sorting is n log n. Okay, so let's see something else now. For this, there is a hint. If you can try pausing the video and try with the hint is this. Use a set, and the key idea is to only start counting from numbers that are beginning of a sequence. Okay. And how you'll check that? If a set doesn't has the previous number, means it is a beginning of a sequence. So let's come here. So you have this array, and if you convert it, if you make a set out of this thing, again this is our array. This is again our set. Both are identical because there are no duplicate elements. But when you apply this logic, you are left with 100, 200 and 1. Because let's see, let's apply this formula for 3. 3 is here, 3 minus 1 is 2. Set has 2, yes. Then this not set has become false. Again try to place 2 here. 2 minus 1 is 2. And set has 2, yes. And set doesn't has 2, false, because set has 2. So by applying this logic, you are left with 100, 200 and 1. And because now you have starting sequence, all possible starting sequences, what you can do is you can try to find the continuous sequence for each beginning of sequence. So I'll have to write here beginning of sequence. So this is beginning of sequence. So this is array and this is a set. Okay. So suppose you are at beginning of sequence of 100. Okay. How can you get continuous sequence of 100? The next one, if you find 101, then it's a continuous sequence. You don't have one. So 100 is a failing here. Not 200. Means 100 is not failing, but 100 is it only is single number with a sequence now, as of now. So we'll like maintain a counter. Currently our counter is 1 because of 100. Okay. Next 200. We don't find 201. So the counter for 200 is 1 only. Will not change it because our counter is not changing. We'll only change it if we found a bigger counter, a bigger sequence, a consecutive sequence. Okay. Now we are at 1. We are at 1. Okay, counter is 1, no problem, we'll not change it. Now we'll search for 2. Does this set has 2? Yes. Let's increment the counter then. Counter is 2 because we have 1, 2. Does this set has 3? Yes. This set has 3. Counter is 3 now because we can find the next number, that is 3. After 3, we'll again ask the same question. Does this set has 4? Yes, this set has 4. So the counter becomes 4 now. Now again same question. Does this set has 5? No, this set doesn't have 5. So we can't increment. The counter stays at 4. So this is our solution. This is our solution. Let's see how we'll do it in the code. And so also about complexity, we are using a set here. So that is that max size of the set can be same as of the array. So that is O of n, and for each array here, for each item we are finding its sequence. So for each item means that is a linear loop. So that is the thing. Either you can try to loop on the set or the array, and because the sequence determining sequence won't change if you have duplicates or not. So because suppose this array doesn't have any duplicates, but if it has a duplicate of 1, let's say, so if you find sequence of longest sequence for this one or the other duplicate one, the result won't change. The counter still stays 4 because of 1, 2 and 3 and 4. So we'll rather operate on the set, because that will give us some improvement in performance. I'll show you that how while we'll submit the solution. So we're looping over the set, and for each item we are checking if is the beginning of the sequence, and if it's the beginning of the sequence, let's start local streak at 1. Streak means longest consecutive number, means counter. And I haven't talked about this, but this thing, we are creating an empty set, not empty set, but we are creating a set out of the nums array, and let's start with the global streak of 0. Means global string means the counter that we are keeping track of. That is our final answer. And if it's the beginning of the sequence, then start with 1 then, because suppose we are at 1, and 1 is the beginning of the sequence, then the current counter will start at 1. Okay, and this is the number. 1 is our number, and we'll keep increasing our counter till we found the next consecutive number. That is, the set has current plus 1, the set has 2, the set has 3, the set has 4. But this will fail when we'll try to find 5 in the set, because that doesn't exist. Then we'll get out of this loop. Till then we'll keep incrementing this counter. Okay, and keep incrementing the number as well. So that will help us to progress forward for this search in the set. And finally, we are updating the global streak, that is the counter, and it is just a simple way of saying give me the max of either current streak or global streak. I just didn't use the math.max library utility, because this was a very simple thing. So, and after we have done this for every number in the array, just we are returning the global counter, or the biggest like frequency. So we have already talked about the complexity. We are not sorting because of the uh, constraint of O of n, and the complexity is O of n for time and O of n for space. Let's try to run this code. Longest consecutive sequence in LeetCode. first consecutive sequence. So I've already tried this, and this solution also has some kind of uh, useful comments, like suppose we have these nums array. So beginning sequences will be 100, 200, and 100 and 200. And why we have used set instead of uh, the nums array itself? Because try iterating over the unique values. I've already discussed why uh, iterating over nums or set doesn't change our answer. Just to prove our point why set is necessary, let's do with nums first. So cases are running, 3 cases, and here it will hit a time limit, I guess. Yeah. So in order to recover of this TLE error, we'll use iterating over set instead. So that's done. This question is done, and this is a solution of this question.